Let's walk through making this custom block to generate the leading and trailing edges of this single panel wing. Note that the output of this block is the leading edge and the trailing edge of only one of the wings, and later on we'll mirror the wing across the fuselage. We'll start with the inputs laid out in this diagram, run a couple of calculations to help us parameterize our model, and then generate our quarter chord, then building our leading and trailing edges around that. Since we're beginning by modeling only half of our plan form, we'll start by dividing our full wingspan by 2, generating a half wingspan variable. And we've input our root chord length, but we'll need a tip chord length by multiplying that root chord by the taper ratio. Now we have all the inputs and calculations that we need to generate our quarter chord and our leading and trailing edges. To make a quarter chord, or the chord that's 1/4 away from the leading to the trailing edge, we'll create 2 points, QC point and QC point 2. We want to orient this plan form on the XY plane so that the fuselage runs along the x-axis. So what we can do to create the first quarter chord point is translate our root point some distance along the x-axis. In this case, that would be 25% of our root chord length. So all we have to do is translate our object by this vector, where we multiply the root chord length by 0.25. So now if we look at our root point, which is at 0, 0, 0, we see our translated point some distance along our x-axis. To make our second quarter chord point, we'll want to translate that initial QC point, half the wingspan in the y direction, and some distance further in the x direction. To determine that x, we'll multiply the half wingspan by the tangent of the quarter chord angle. We'll keep our z component at 0 millimeters to ensure our result is all coplanar. We'll check the visibility of that chord. And now if we feed our QC1 and QC2 into a line block, we've generated our quarter chord. Now moving forward to the leading edge, we'll do something similar. We already have our root point, which will feed into the first point of the line that creates our leading edge. To generate the second point, all we'll do is translate that second quarter chord point a quarter of our tip chord length in the x direction. That generates this point, which we can feed into our line block to generate that leading edge. For the trailing edge, we'll again do something similar. First translating our root point by our root chord length to make our initial point, and then translating our QC point 2 by 3/4 our tip chord length. That'll generate this second point, which we can feed into our line block to generate our trailing edge. Now viewing this from the top, we can imagine our fuselage here on the left side of these lines, and we can feed our leading and trailing edges into a curve list, set those as our output, and now we've finished creating this custom block. And because we set this up parametrically, we can now go into our inputs and change any of these around, maybe adjusting our wingspan or our quarter chord angle to test out different variations of our leading and trailing edges.